All right. Hi, everybody, and thanks for tuning in to my talk. I titled it Unleashing More Kotlin Power, because as we all know, Kotlin is already pretty powerful. But this time we're talking about the context of full stack web applications. So before we dive into this, let me just super quickly introduce myself. Hi, I'm Sebastian, and I work as a developer advocate at JetBrains. I mainly focus around topics concerning Kotlin and Kotlin JS. And I would say that recently, most of my work actually revolves around Kotlin JavaScript specifically. And while it's not quite as popular as some of the other targets for Kotlin just yet, I think it bears immense potential. So I kind of try to share as much knowledge about it and kind of get people excited about it as much as I humanly can. So as you can maybe already guess, since this talk will be about web applications, we'll definitely see some Kotlin JS tonight as well. So I really wanted to present something that you folks probably haven't tried before, and something that might come in handy for you sometime down the line. So I've really done my best to kind of cram all the parts into this talk to make good on the promise of the title for the full stack application. So we're going to see a little bit about a server, a client, the multiple execution environments. I think it's going to be a blast, and hopefully we'll all learn something new along the way, especially you folks. So what are kind of the goals for this talk? Well, so I'm going to walk you through a mini example project, first of all. I kind of want to provide a rough but realistic overview of the typical tasks that are involved when you are building an application that consists of multiple components, and then also really dive into the implementation detail for such an app as well. And in a later part of the talk, we're also going to see how we at JetBrains are actually using a similar approach to kind of what I'm walking you through, both for very small products like just internal hackathon projects, all the way to our newest products that we're actually shipping. So I hope that I'll be able to instill some excitement in all of you when it comes to the tech, and ideally to the point where afterwards you'll go hands-on and try some of this stuff for yourself, even if it's not in production. So without kind of further ado, let's just build something, because that's probably the best way to learn something. So the example project, I really want to keep kind of simple and really constrained to the essentials. So what I kind of want to propose is a small shopping list. So just a simple input field that allows you to add a couple new entries to the list, and the option to just click on them and have them disappear to tick them off. So as a really small cherry on top, I'm going to replay this animation again. We can add a couple of exclamation marks while we enter an entrance, and we will just parse these exclamation marks and generate a small priority number based on it. So of course, since this is supposed to be a full stack app, we want to send all this information to a server, and then ideally persist it there so that if we access it from multiple devices, right, or if we access it over multiple reloads, we always see the same shopping list. So let's kind of formulate a game plan based on this. For something like this, what you can probably imagine a basic architecture to look like is something like this. So on the left side, we start with everything that runs on the server. There are tons of server-side frameworks for the JVM, so we'll choose one of those, and we'll implement the whole backend in JVM code. Ideally, at some point, it should also integrate into some kind of database, though for the purpose of this exercise, we can always just mock that part. More importantly, we of course want to expose some kind of HTTP server, and we need to somehow serialize and deserialize our model. For that, we need to agree on some kind of common description or abstraction for our model, which is going to be the elements in our shopping list. And then if we go quite symmetrical over to the client side, we need to make sure that our system over there speaks the same language, so to say. So it needs to be able to serialize, deserialize the same models, make requests to our API, and of course, include all the logic for the client as well. because modern web browsers all speak JavaScript, this makes sense to have this written in Kotlin JS. So since we want to build all of this in Kotlin, we also want to make as much use of code sharing as possible, which is why we would define our shopping item model in Kotlin common code. So just code that's pure Kotlin, doesn't use any platform-specific libraries to define our model. Now, when we start translating this into kind of the structure of our source sets, we get a very similar pattern with just 3 source sets. All our code for the JVM backend goes into JVM main, front-end JS code goes into JS main, and code that's platform agnostic stays in common main. So now that we kind of have a basic idea of how we want to structure the app, I would say it's time to actually start implementing. I usually like to start with developing the actual service as an API first, because then I know what kind of data I want to and can actually offer to my clients, and then how I can pull those and we can tackle later. So let's do this. As a first step, we kind of need to agree on a framework that we can use for the server side. On the JVM, there are tons of different libraries that can help with spinning up a backend service with Kotlin. Because, well, as a JVM language, all the Java frameworks can, of course, also be used with Kotlin. And sometimes they even offer specific support for Kotlin, which means we could write our application with Spring Boot, Javelin, or Spark. But there's also members of the Kotlin community building frameworks like HTTP 4K, for example. For this demo project, I'm still going to choose Ktor, though. So if you haven't heard about Ktor yet, everything you need to know is written in its tagline. It's easy to use, fun, and asynchronous. And I mean, if it's fun, then what else are we supposed to do? No, what I really enjoy about Ktor is that it's a very unopinionated and modular framework, which means we can write tiny applications like our shopping list without having to wade through tons of configuration or annotation black magic, but we can still expand upon this and we can still build even more complex systems without running into any kind of bottlenecks that Ktor would produce. Another cool thing about it is that it's an official JetBrains project, which is an added bonus because, as we'll see in a bit, it's actually also a multi-platform project in itself, and it integrates really well with some of the other official libraries we have, for example, Kotlin X serialization. If you've never touched Ktor before, let me just give you the world's shortest Ktor tutorial. To spin up a very basic HTTP server with Ktor, we include the relevant artifacts in Gradle first. Then we start an embedded server, in this case just on port 8080, and we use the routing DSL to say that any GET request to the /route should be responded to with hello Ktor. One button press later, once we hit the run task, we have a backend. It's not quite the backend we need yet, but it's already a backend. So at this point that we know that we can respond to things quite easily, it would make sense to agree on a minimal interface to kind of know what operations we want to support, and then later translate that into the web user interface. So typically when people write these demo applications, they build CRUD apps, C-R-U-D, which stands for create, read, update, delete. Honestly, if you've seen the demo beforehand, updating isn't really all that important to us in just a shopping list. So we are going to have a CRD or CRD app. So we're just going to focus on these 3 types. For our shopping list to work properly, we first need to be able to add new entries, right? Which we would do with the post method, and then we'll just post some JSON there. In order to display the list in the front end, we would also want to support a get on the shopping list, which would ideally return a list or an array of all of our shopping list entries. And then finally, given a specific ID, however, we'll define that later, we also want to be able to remove individual items as we tick them off. So we have a mental model now what our API is supposed to do. We've kind of already agreed on the JSON structure as well. So it's time to define our model. And this is the thing that we want to work with and also send over the wire in the end. So we already kind of know that we want to share our model with our front end later on. So what we can do is we can take this simple data class we have here, and we'll put this into common code, which means we'll be able to access it later, both from Kotlin JS and from the Kotlin JVM side. We are also going to be a bit clever here, and inside a companion object for our shopping list item, we are actually going to associate a path with this class. Now, why would we do this? Well, we can use the information for this later, both on server and on client, to kind of make sure that both of the sites use the correct URL when they access items of the type shopping list item, right? So this is going to prevent a bunch of possible typos down the line. We'll hopefully see that in a minute. So before we move on to kind of exposing all this data through our API, we still need to have kind of a way to convert our Kotlin object to its, well, JSON representation. And we're going to use Kotlin X serialization for this. If you haven't heard of this library before, it's essentially a library that allows you to convert Kotlin objects into their textual representation and back again. Now, for enabling serialization for a simple class like our data class here, after we've added the Kotlin X serialization dependency to Gradle, it's literally just adding a single annotation, and we are done with this. Now that we kind of have the common part out of the way, we can actually get back to writing the JVM server. And I've alluded to this a little bit already before, but I'll be happy to say it again. Lady Luck is on our side here because Ktor really loves Kotlin X serialization. So we can kind of follow the instructions on the Ktor website, and really all we need to do is add 2 lines to tell the Ktor backend that content negotiation should be enabled and that JSON should be used as an exchange format. Now, Ktor automatically configures Kotlin X in the serialization in the background for us. And pretty much all that we are left with are 2 new powerful ways to communicate. Because now when someone gives us an HTTP call, we can either respond with a Kotlin object directly, of course, provided that it's serializable, or we can just receive a Kotlin object directly. So the whole serialization, deserialization shebang is abstracted away from us, which in my opinion is quite delightful because it makes our job of implementing our 3 HTTP methods so much easier. In fact, besides the few lines of configuration that we saw beforehand, everything you see on this slide is the whole business logic we need for the backend. So let's assume for a moment that we just have a collection of shopping list items called, just shopping list. Again, for the sake of demonstrating, this could just be a mutable list that is stored in a top-level declaration on the server. But the amount of work that you would have to go through to replace this, for example, with a MongoDB instance is absolutely marginal. It wouldn't make much of a difference here. But let's actually go through this line by line. So inside our routing block, we first group all the routes by the shopping list item path. So all the routes that are inside this block, they will be children of the /shopping list route. And now if someone calls get on /shopping list, we respond with the collection of shopping list items. Ktor and serialization in the background then make sure that everything gets turned into the proper JSON form. And yes, as you can see, it even works for collections or lists of serializable objects, like in this case. Now, how do we handle adding a new item via a post request? Well, in kind of the most straightforward way, we can just receive the item again as a Kotlin object, add it to our collection, and respond with an HTTP OK. And deletion, well, is the most complicated of the 3 because it is actually 3 lines of code and not just 2. We turn the parameter first into an integer, remove it from our collection, and we are done. So as you can see with Kotlin X serialization working kind of as a team with Ktor, all the grunt work has kind of been abstracted away, and we were able to describe our whole setup in just a few lines. It's ready to spin up. So at this point, we can actually move on to writing a web client at this point. So let's first kind of move on to structuring our front-end application that looks a little bit like the one in the video I showed in the beginning. It's probably best that we first get either a basic understanding or a little refresher on how a Kotlin JS project works. So first of all, we need to have some kind of home for our JavaScript application, some kind of HTML page. That's just because we can't have free-floating JavaScript files that are executed in the browser. They need to be in a site, even if all the site does is include the JS file. Then we, of course, need to write an application, app.kt in this example. If we want to, we can, of course, also include artifacts from common libraries, which we're going to do. And once we funnel all of this through the compiler, we end up with our index.html file and the corresponding JavaScript file in our output build folder. This is already nothing too complicated, but it does show us one issue because we are building a multi-platform project. So we don't really want to have to manually copy around the resulting JavaScript files just so that they can be served from a server somewhere. No. So what we want to do is we want to serve them with Ktor as well. What needs to happen really in the background here is that we need to, when we build the Ktor application, we also want to compile our JavaScript frontend, then copy the resulting artifacts into the right directory, and then run the Ktor server, so that it always kind of runs with the newest version of the frontend and works well together. Might sound complicated at first, but thankfully we have a strong ally, everyone's favorite elephant, you guessed it, Gradle. So all that's kind of needed to do the inclusion is described in the snippet. If it looks a little bit scary, don't worry. First of all, it's not like we have to kind of come up with a snippet on the spot every time we want to change something in the application. It's closer to like a one and done thing. The really interesting parts of the snippet anyway are these two lines where we just make sure that the artifacts for our application are created and included in the build when we run the JVM application and build it. Apart from that, the snippet is just minor optimizations between production and development mode and making sure that all the class paths are adjusted properly. At this point, we will already have our front-end application, if we ever build one, available in the resources of our Ktor backend. And we can serve those files once again by adding 2 significant lines, 3 lines in total, to our routing block of our Ktor application. So now if someone would visit the index.html at the root of our API, they would see, well, currently nothing, but at some point they will see our front end there. If we want to have URLs that are even prettier, that don't include the index.html in their name, we can, of course, define the appropriate rewrite, access the file directly. That's certainly going to work. So finally, it's time to write some actual Kotlin JS. First of all, we can start with writing the counterpart to our JSON API. So because if we have that already, we can kind of rush out the user interface in one bit. We can wire it up directly. So I may have briefly already spoiled this slide before, but the Ktor project actually isn't just server-side stuff. It also includes Ktor clients, which are available for multi-platform, meaning that with a very similar API to what we had beforehand for the server, we can now use them to make HTTP requests, but they also have features like WebSocket support. And again, they work wonderfully with Kotlin's concept of coroutines. And yeah, in case you did not know beforehand, coroutines are multi-platform, which includes Kotlin JS. So we can just use them in our front end later on without giving it a second thought. And by the way, of course, if you are interested in doing Kotlin Flow, that is also going to work in Kotlin JS. Now, everything we're kind of doing on the client side is going to be very symmetrical to what we've done on the server. So I don't want to spend too much time on it, but I just kind of want to show you the symmetry, right? So first, the counterpart for content negotiation on the server is the JSON feature on the client, needs a single line of configuration to tell it to work with the Kotlin X serialization library on JS. From here on out, we kind of just define the CRD methods. In our case, we call them get shopping list, add shopping list item, delete shopping list item. To keep it a bit more generic, I've introduced a variable endpoint in this code snippet, but honestly, as long as you're just working from the same host, you can just go directly to localhost 8080 or wherever you're hosting your application. So from an implementation standpoint, there shouldn't be too much of a surprise here. It's get, post, and delete methods. Yeah. And this is the second time where we actually reuse the shopping list item path, which we defined beforehand. And I think, again, this is actually kind of a clever thing to do because if you look at this API client, you can kind of see that there aren't really any strings for endpoints in our API, which has this lovely side effect that if we at some point decide our shopping list is actually more a to-do list, then what we can do is we can go to the common code, refactor the name of the endpoint, recompile the application, backend and frontend will both know the new endpoints, will be perfectly in sync, and serve and consume items on the /to-do instead of /shopping list, for example. Well, now finally the time has come to build something visible, so a real front end for our application. As a framework for this, we can use React, which is a good choice when working with Kotlin, simply because JetBrains actually provides type-safe wrappers for React and its APIs. So you can kind of see here as well that the h1 tag, it hints at the fact that there's also a type-safe Kotlin DSL going on here, which allows us to describe DOM elements. We'll see a little bit more about that later. So yeah, the simplest Kotlin React application looks a bit like what you can see here on the screen. Of course, not much is reacting yet. So let's kind of decompose the application that we plan to do and then replace kind of this hello world code just with the snippets of the individual components. So let's have a look at the screenshot again, see if we can figure this out. So in general, we need to hold our overall application state, and then we can decompose our project into 3 components, if you will. So a static header, then the list of entries, and then an input field. Now, unfortunately, I don't have time to dive too deeply into the concepts behind React, but I hope that with the code samples I have on the next slides, things will still stay pretty clear. The nice thing about the fact that the Kotlin wrappers also support the more modern features from React, such as hooks, the code snippets are quite concise as well, and are I think, rather easy to grasp. So first, let's start kind of with the application state, which is just a functional component. Really, all that we are doing here is we are defining a state container for shopping list items. So the other thing we want to do is that when the page first loads, we want to fetch the current state, so all the shopping list items from the remote API using a function get shopping list, which we've defined from in our local API client, and then we just fill our local state container. It might look a little odd when you see it at first, but there's not much black magic going on here that would be too different from if you would write the same code in JavaScript, for example. Then the second huge component is the static headline. This probably didn't even deserve a slide in the first place, but again, it's just a nice reminder that we are actually not writing any HTML when we want to render stuff out. We're not concatenating any kind of strings or interpolating strings, but we have a type-safe DSL to describe our markup. And this actually has another big impact, and we'll see how this comes in quite handy in the next component, because it allows us to mix a description of our markup of HTML with Kotlin logic. So what we can see here is the implementation of the entry list. And how we define it is that we have an unordered list HTML element, which we want to fill with content. So how do we do this? We do it the same way we would always do it in Kotlin. We can just, for example, sort the list first, and then we just create an HTML list element item. So yeah, in the same way, we can also actually directly wire up what's supposed to happen when we click an item. So we want to push the deletion change to the backend using our API client and request the new state. Because we are using React and this kind of React store, once we have obtained the new shopping list items and we kind of put them into our store, then our UI will automatically re-render and update. We don't have to do anything else here. But you can see that it's very easy to mix markup with Kotlin, and it still stays rather clear. You can also see here that using coroutines, for example, comes very natural without any kind of extra ceremony. So we can now display and take items away. So let's quickly add the finishing touch, which is the input field. Now, kind of for brevity, I've omitted the detailed implementation of the input component, but the essential point here is the same. So we, what we do is we provide an onSubmit handler, which does the tiniest bit of logic, then submits the list to the backend before we refresh our UI. Yeah, the logic really is just counting and removing the exclamation points so that they are converted into a priority value, which we have in our shopping list item definition. And once we actually have glued together these components, it's already time to pop the champagne or the cider, because we've achieved the goal that we kind of set out for ourselves. So the overarching process, I hope that we need to get through to do kind of a very basic full stack application has hopefully gotten a little bit more clear. Before we round everything out though, I kind of wanted to include two interesting places where Kotlin.js can be seen in action, one very small and one very big. Let's start with the very small one. In fact, a project that we built within 48 hours during one of our annual JetBrains hackathons in a team of 4 or 5 people. It's called Code Quiz. It's a multiplayer game aimed at helping people test their programming knowledge and, well, of course, specifically the Kotlin knowledge. So the way that it works is that a presenter with a big screen or with a big screen kind of shows a code question, and then the audience who is connected via their phone on a web application can lock in their answers and collect points. Now, architecturally, this is very similar to what we've already described. It's a multi-platform project, uses a bunch of the technologies we've already gotten to know. The main difference here is that it uses WebSocket communication to communicate between the front end and the back end, but still both sides are implemented using Ktor, and all data models are shared using Kotlin X serialization. We do something very special here, or well, we do something that's kind of convenient and that's provided to us by Kotlin X serialization, and that is polymorphic serialization. So we can actually have a sealed class hierarchy of game messages, and we can serialize and deserialize those game messages and send them over a single WebSocket, and everything will still work properly. This is actually a non-trivial problem, so I'm very excited that the folks with Kotlin X serialization have come up with such a smooth solution. The interface then in the front end, both for web and mobile, is written with Kotlin and React. It uses a couple of additional components that we pulled in externally, for example, to draw graphs or to do some animations. So if you've ever participated in a hackathon, you probably know that these are very tough and hard work. And it's precisely why I believe that Kotlin.js and Kotlin multi-platform was very instrumental for us. Well, firstly, most of us were actually Kotlin developers, which means it was, if we had the same language on the front end and the back end, it was easy for people to jump between changing parts in the user interface, changing parts of the server-side quiz management, and everyone could speak in terms that they understood. Because Kotlin X serialization provided us with this type safety through our whole stack without us actually having to agree on like a third-party interface language, it made us a lot more confident in working at kind of related pieces of the code at the same time, and even on the game messages, so the actual communication structure at the same time and as a whole. Because really, it's a lot less scary changing a class when you have a compiler looking over your shoulder, doing what are almost a form of like integration tests at the point where you have multiple parts of your system. And yeah, after 48 hours of prototyping and iterating on this, we had something to show for that we were actually quite proud of. And it paid off. We won the entertainment category in our hackathon, and we've used Code Quiz actually a couple of times since then. Most recently, you could have seen it at KotlinConf. If you were there, you could have come to our booth and win some prizes if you knew a lot of Kotlin. Apart from that, Anton Keks's talk on Kotlin Puzzlers, which is kind of known for its interactivity, that one was also held with Code Quiz at the last KotlinConf. Here's a couple of impressions of how that looked like. Of course, I'm not implying that Kotlin.js will bring you success in your next project or hackathon, but it certainly helped us succeed in kind of a high-stress situation, and maybe you can find a way where it could do the same for you. The whole Kotlin multi-platform journey for us obviously doesn't stop at hackathon projects. We are using currently Kotlin JS inside JetBrains to build parts of our newest product called JetBrains Space. So if you don't know what JetBrains Space is, it's our integrated team environment. So this is supposed to unify the whole development story, right? From team organization, communication planning, but also sharing code, building, and delivering software. As you can probably tell, it's a very complex system that's made up out of a bunch of different components. But the main way that you interact with it is actually through a front end written with React and Kotlin JS. And of course, the Space team also makes very heavy use of code sharing between different platforms, which include JS on the web. Then we have JVM on the backend and native on iOS. There's actually a great talk by my colleague Maxim Mazin, if you'd like to understand a bit more how Kotlin is used in a complex system like JetBrains Space. It's called very aptly Kotlin in Space, and you can find it on YouTube from last year's Kotlin Conf. So just to kind of recap, we've seen a bunch of things today, hopefully some that were interesting and inspiring to you. We saw how kind of Ktor and Kotlin X serialization have powerful synergies when it comes to writing concise APIs and even consuming these concise APIs afterwards. Hopefully you've also seen that there isn't too much magic involved when it comes to writing simple front ends with Kotlin and React. And yeah, you should have probably learned that we are actually building products with this technology, and we are thoroughly invested in it. So I kind of want to end on a call to action, because sitting back and watching me talk is a great first step, but even better would it be if you tried this stuff out yourself. So yeah, give Kotlin multi-platform and Kotlin JS a try. It can be a very fun technology to kind of broaden your horizon while sticking to a language that you probably enjoy. And if you are excited about this kind of stuff, I actually have some great news. The example project that we've walked through in this talk, we've actually also made available on play.kotlinlang.org/hands-on. And there it's actually in the form of kind of a long form tutorial. So you can go through it at your own pace. You can revisit topics you struggle with. It has a lot more explanations surrounding some of the more specific topics as well. And yeah, it also comes with, of course, a template project and a completed sample project, so no one has to sit down and start transcribing my slides. While you're on play.kotlinlang.org, you can, of course, also check out some of the other tutorials we have there. For example, on React and Kotlin JS, or we also have a bunch more on Ktor and writing backends with Ktor, the different ways on how you could organize your routes, for example. And there's just a bunch of learning materials there available completely for free. And we hope that they make your learning journey kind of fun and productive. Apart from that, I can only say thanks a lot for your attention, and let's stay in touch. I really like talking to folks about Kotlin in general and Kotlin JS, I think, in specific. If you want to get some weird tweets in your timeline around Kotlin and web technology, feel free to follow me at sebi_io. I'm also very happy to talk there or via email or on the official Kotlin Lang Slack channel or wherever else you can track me down. Yeah, and let's see if there are any more questions right now. And apart from that, thanks again.
Thanks, Sebastian. Yeah, there are a few questions. I'm sure if you can see them and you can read it yourself.
I cannot.
Okay. Right, I can read it. Can you see them now?
On Slido? Let me reload.
Yeah, on Slido. Well, it's fine. I can read it to you.
Yep.
Okay. First question from Justin. Thanks, Sebastian. Does JetBrains have further plan for pushing Kotlin JS support out in the wild with frameworks like React, Vue, and React Native?
So we have very good support for React. I know that there are some community efforts going on to trying to get Kotlin JS to work nicely with React Native as well, but those I think are still in their infancy. The problem with some of the other frameworks like Vue.js, for example, or Angular, is that they usually provide some kind of custom build pipeline that, for example, interprets their markup or their kind of templating language. React has this added benefit that because it uses JSX to kind of build its DOM trees, it was a lot easier for us to integrate, and it's currently the main way. But there are actually also some community initiatives for providing pure Kotlin JS frameworks for writing web applications. One of them that would come to mind is Fritz2. The other one that would come to mind is Kvision. And these are kind of they're kind of different approaches, but yeah, they just try to make it easy to write pure Kotlin JavaScript front-end applications with the framework.
So, that's another question. Can we use Kotlin JS with Angular?
I think I just answered that.
Yeah.
Currently, so of course, actually, the answer of this is a little bit more complicated than what I said before. You can't use Kotlin JS with Angular as in that you can write your whole application with it. But where we also see a lot of power for Kotlin JS is in kind of a library workflow. So the idea would be that your business logic, for example, you write once in Kotlin, and then you package it as a library that you can consume from Android and iOS, for example, and also from JavaScript. So if you kind of have this hybrid approach, then there's nothing standing in the way for using Kotlin JS with other frameworks as well. You just won't be able to access the framework's APIs in a very easy fashion. The other way around, going from the framework into Kotlin JS, we are working very hard to make this like the smoothest experience you can imagine.
And just on the same page, so can we use existing JS TypeScript library with Kotlin JS, such d3.js?
Yes, you can. So there's a couple of ways how you can do this. First of all, the easiest way is the dynamic type. So what you can do is you just in your Gradle configuration, you can type implementation and then npm, for example, and you can just pull something in. At some point, this is you can declare this to be dynamic, which means your type checker isn't gonna do something, but you can use it directly. The other ways that you can do this is through our new experimental project called Ducat, which is the Kotlin declaration converter, which has as a goal to automatically convert the definitely typed descriptions, or in general TypeScript definitions, into Kotlin headers. If you are specifically looking for something like D3, there is another project called Data2Viz, and these folks actually took they kind of took the ideas of D3 and they ported it to Kotlin and to Kotlin Common, which means you have something that's very similar to D3 available as pure Kotlin code, and then multi-platform and of course JS as well. If you have more questions regarding kind of using these kind of things, I could recommend that you either check out my own talk, by the way, from last Kotlin Conf, titled The State of Kotlin JS, where I go a little bit more deeper into the tooling, or you can wait another 2 days, and on Friday I will be giving a talk called Kotlin JS Today and Tomorrow at the Conference for Kotliners, where we will also tackle the newest developments, also in regards to interoping with the JavaScript ecosystem.
Yeah, and the last one is not a question, it's just a thank you and looking forward for your talk to Friday. You just mentioned it.
Awesome, great. I hope to see a lot of you folks in the virtual audience there. I won't be able to see you, but still.
Yeah, thank you so